Okay, so first up today we'll have a quick talk about the assessments and the possibility of working, going through those during break. So we've covered a great deal of the stuff, I guess, that will enable you to get started on these two assessment tasks over the holidays. So assessment task 1, fairly much everybody's done that, and that was in the main that was done to really good standard. So got fairly high hopes for the class, having seen everything submitted there. Assessment task 2, research assignment, when it opens. Was that my Word document here? Yeah, okay, there we go. So standard cover sheet, etc. Have a look through that, put your name on there. But the crux of the task carried on here. So this is about getting you to research the basics of a whole bunch of materials. And I introduced you to OneNote at the end of last week's session, which is a good repository for all this sort of stuff. What's that? Did I? Yeah. Yeah, I can have a chat about that again if you want. Have you used OneNote before?
I can't remember that.
Yeah. All right.
Sorry, could you?
Yeah.
I've often wondered how OneNote.
Yeah. Okay.
Really works.
Okay.
Ah. Yeah, that's what I was feeling when I went to the tour.
Ah, right. Okay.
Yes, so I
Yeah.
actually missed that. Yes.
Okay. Well.
Yeah.
So. Oh, looks like I've got to sign into the portal again. Excuse me.
Yeah. That really won't annoy you. Because OneNote takes up a huge amount of your like hard drive. It's like a gig or something every time it downloads and updates or something.
What? Yeah.
What is in this one?
Yeah. What's the purpose of this thing? No, it's really good. So. When it gets happening. So. So just there under Microsoft Office. So I've got these are so for my other materials and methods class for certificate 4, I actually make this as an assessment task for them that they have to do because their research assignments are far more involved, and so they like what you guys cover is residential in a semester, then commercial later, and you've got the construction side of things and materials separately, etc. So you guys get a lot more time to go through things. In the certificate 4, they're flat out through residential through to commercial in one semester, and so what I get them to do is compile these OneNotes and just start getting everything in there to form those reports. But basically, it's handy if you guys want to do the same thing. So you've got, I'll go my notebooks. That's one I just set up just the other day. I wanted to set this one up separately. I don't think I've put anything in here. No. Okay. So back. I'll share Christian's. So I showed this one last week. Show that to you. So for some of you, this will be a bit of deja vu again. So Christian's put this one together, and he's split it up: roof structural, wall structural, floor structural, roof cladding, wall cladding services, Australian standard codes, images, etc. If he's put anything in there recently, that'll be updating. So he's sharing his OneNote with me, so I can go in there and I can see all the stuff that he's putting on there as he's putting on there and as he's updating. So it's one of those. It's a repository for all this information that you can share with colleagues or people that you're working on the same project with. You can put together basically it's like a digital version of a filing system, and it can be used for all your materials and building product information. So
he's just like, rather than me, I'm just thinking about what I did. I made a Word document. I started putting links in the Word document.
yeah,
He's put this in the links in the OneNote, and any other things that he's got, like a notepad, physical,
yeah,
in there under those topics.
yeah. So it can so it can work like a notepad in terms of you can so just fascia, pitch, ridge, underfill, and so on. He's put some bits in there, things to look at, etc. You can just type in any notes, or you can grab URLs. You can chuck in pictures in there as well. So what you might want to do is, so you chuck in a URL for Kingspan, and you might want to show a bunch of insulated roof panels, etc. like underneath that. So you can go, oh, that's that one, that's that one, that's that one. However you want to organise it. So if I flick back to our assignment, oh, and also and I've got another student who's using it in a different manner as well, which I thought was also clever. What he's done, he started producing his report in OneNote. So he grabbed the assignment literature, dropped it into OneNote, and he's using that as a template, and then he's just filling out his report within OneNote. So he's using it essentially like a Word document, but OneNote actually allows you to break it into separate sections as well, and you just click between your different headings. And that's another thing you could do as well. You could grab this assignment literature, drop it in to OneNote, and then you can fill out your sections there, and then if you wish, you can copy all of that, drop it into a Word document, do some formatting, etc., make it a much nicer report. So yeah, so various different approaches there. But our assignment, so provide a series of photographs. So we've got it broken into, I think there's 13 questions in here. First one is provide a series of photographs that show a range of common building materials used in your home. For each of these categories listed below, provide at least 3 labelled colour photos of different materials. So you could go around your house, or it doesn't have to be your house. It can be another building, or even if you're struggling to find some things, get some pictures from online. But you can get all those pictures, put them on your computer, and you can drag those pictures straight in to your OneNote as well. It doesn't have to be online information. It can be information that's on your computer, and you can just drag those pictures in there, and then from that store that, move on to the next question. Got question 2. Timber and timber products. Visit a major timber supplier for information if required, or find this information in Australian Standards 1684.2/2010. Can anybody tell me what that Australian Standard is for?
What's that?
This one here. Can anybody tell me what 1684.2?
That's the classification on the timbers, on their grades of ability to withstand things.
Close. 1604 is one. 1684. That's residential timber framing. So that's the Australian standard that tells us how we go about using all of that timber. So we've got 1604 for timber classification and timber qualities, and then 1684 for the implementation of timber within framing. So it's the residential timber framing code, and point 2 is non-cyclonic. So it says visit major timber supplier for information if required. So by visit, that visit can be online. That's basically how people get a great deal of information these days is online, and so you can do that research online. Probably a really good location for that is a website called Wood Solutions. So there's a lot of information on Wood Solutions. there. Asks you to list the different types of hazard classes applied to timber and their level of exposure. Does everybody remember covering that one in class? We got so hazard class 1 inside above ground. Can anybody think of what hazard class 2 is? Yes. So we've got hazard class 1 through to hazard class 6.
2 was your next version of one where you define as structural, but not as good as 3, better than 1, and had a little bit of turnover resistance as well.
Yeah. So yeah, no, that's pretty close. So yeah, so we've got hazard class 1. That's just our, timber in its natural form. Well, actually, no, that's probably not the best way of describing it, but that's our Pinus radiata in its natural form. No termite treatment on it. It's all orange colour, natural. That's our hazard class 1 timber. That can only be used inside, above ground, not exposed to termites. Hazard class 2 has been termite treated. What's that? Yeah, H. So yeah, which one do we use? Which one do we use above ground, outside? Any advances on H4? H3 above ground, outside. Then H4 in the ground. H5 in wet ground, so retaining walls, things like that, things that retain moisture behind them. H6 in marine applications. So list some common defects to understand when using timber, describe durability and natural durability. Sketch a couple of examples of improving durability through design detailing. So this will get you to actually do some sketches. And it is still a very important skill to be able to hand draw and to sketch. Look, you can do your sketches on CAD. That's fine. Do your details. The main reason I've kept this one in the sketch examples of improving durability through design detailing is that the actual act of drawing things, to work through things, helps entrench details in your mind. So when you start drawing stuff out, you actually start thinking, or myself, I start thinking more clearly about all of the components that are involved. And so you'll see through here there's a couple aspects where you're asked to sketch things, and if you don't go sketching things, if you don't go incorporating those sketches you've done yourself into your report, I'll have to get you to resubmit with those sketches. So a few people miss that, a few people don't take that so seriously, but I think it is actually a very important thing to be sketching stuff and working through those details. Super important because it's a bit of a cliche, but the devil is in the detail, and a lot of building failure, etc., is because of misunderstood details or people who didn't particularly work through things, and a great deal of expense on construction sites still, and I think it's almost a bit of a travesty, is that construction gets held up while builders refer back to architects and drafters, etc., in regards to details. They go, how are we going to do this particular thing that you've told us to do? And people are standing around on site or sitting around at home waiting to go back to site because details need to be clarified. If you are working as a drafter, I think it is vital that you get to know your construction details really well, and it's going to be a continual learning process. You're going to have to resolve details and come up with details for certain connections and joints and things like that, and you all the time, you're going to be learning new ones all the time. This one's fairly simple. So sketch a couple examples of improving durability through design detailing. Can anybody think of things, any construction details that do help keep timber? This is something we haven't covered in class, so it's fine if nobody can think of anything. So to keep, to help the durability of timber, to keep it in.
In your construction detail of your
Yep.
level outside the line, so there's an important detail.
That's an important detail, and so that's going to help with your timber durability, help keep the timber in, improve durability through design detailing. Anything else? If I was doing a deck outside, so an outside timber deck, a lot of that is exposed to moisture fairly continuously. Any sort of things that I'd be thinking about?
Varnish.
What's that?
Varnish.
So yeah, varnish. Not exactly design detail, but I'll award points for that. But yeah, but any of the things that, like, if I was telling the carpenters to do a certain thing on site, any other ideas of what I'd tell them to do? This is before any coatings are applied. Yeah, so yeah, we think about a bunch of structural things. Well, I think if I'm using timber stumps, what do I want to do with timber stumps?
I was thinking the green sheet you put in, I'm trying to think of was it? The estate of green stuff.
Copper chrome arsenic.
Yeah.
68. Yeah. Okay. So yeah, once again, that's a treatment. Has anybody seen post shoes before?
Yeah.
So on your verandas.
The timber sits on a steel bracket.
Oh,
So yeah,
steel bracket.
block of concrete.
Go in the ground, or it can be just a.
Yeah, you were showing that to us the other day.
Yeah.
Like last week.
Yeah.
Frame, kind of frame.
What's
kind
that?
Of frame. Is that a kind of frame?
That's what this does, and so this is our soil here. What that does is it picks the timber up away from the ground. So if any of our little termites and so on want to eat that timber, they can't get to it very easily. They have to climb up here. They have to build a mud nest to get to that piece of timber. Also, for any water on the ground, this timber is not going to be in contact with that water. It gets rained on, the water drips off. It's not continuously kept wet. If there's a bushfire going through, embers on the ground, etc., that piece of timber is not going to burn very easily because the bottom section of it is steel. Some other design details, like things that get rid of water. If I use a piece of timber on the top of a railing like this, so this is our railing, top of the balustrade. A really good idea is to do a slight sloping cut. Well, that's a exaggerated sloping cut, but a slight sloping cut, so that the water drains away from that piece of timber. Other things, this is something you'll see a lot on pergolas and things. If we've got our rafters heading like that, for example, this portion of our timber is fairly vulnerable bit of timber there, and where we have all our end grain going like this, that's a position there for water droplets to sit and start soaking into that timber. You've probably seen that on pergolas, things left outside. That's where they start rotting.
When they make put up a couple of dollars over the years, you know the shoe straps that you can nail to the wall, nail to your pergola. I noticed, I wondered about this when I put them up, that corner is cut out of it, so the saddle, when it comes in about an inch for the saddle where the timber sits. Is that right?
I'm trying to think exactly what you mean. Yeah.
So you're saying this bit there, right?
Yeah, that piece
so
of
if you
timber.
look at your saddle comes down as a cutaway like that.
Ah, right. Yeah.
So that's coming back that way.
Yeah.
You know, that's going that way. And then of course that comes down like that, so that it's the timber sits in it, flush to there,
Yeah.
but that bit there is cut away.
Yeah. I think that might actually be a manufacturing thing, but I can't be sure. That might, yeah, that.
Because I always wondered why didn't it come up flush?
Yeah.
And
I don't know actually. That's a really good question. Yeah, there might be something in that as well. Yeah.
so they use those samples on the back of the farmhouse, and you know, the Oregon. And interestingly enough, all of them bar one, which is the one that's exposed to the western side sun. All of them are fine. That one's got quality. And I don't understand. Well, I've been trying to figure that one out.
Yeah. Well, and possibly being exposed to the sun helps with that dry rot as well. That's something I haven't actually investigated, but possibly that's that's your difference, or maybe that one's just exposed to more moisture. An end one. But typically we get this, as you say, this dry rot happening on those corners of our timber. So a very common detail that you'll see is actually a sloping end cut of the timber as well. That enables water to come along here and run along that face, and then gets a bit of speed up and then drops off rather than gathering in there. Or we get section where we'll do that. So this end bit is actually a little bit more protected from the weather than that end bit there. So that's a very common detail as well to help preserve the ends of our rafters. Well, actually, basically it's chopping off the end of the rafter that would start to dry rot and then harbour moisture and then rot the rest. But there are a whole bunch more details. So think about those details, the things that help keep timber durable. Concrete products. So we've covered a bit in regards to concrete. So can anybody answer me what is reinforced concrete? I think Annie, you would be able to answer that one fairly well. Well, sorry to put you on the spot. Anybody else want to answer what is reinforced concrete? Yeah.
So to improve the concrete structures?
Well, certainly it's certainly improved the con. So if I was to add reinforcing to concrete, what would I add as the reinforcing? Anyone? But not so.
The steel.
Yeah. So so steel is really good in tension. Concrete's really good in compression. Add them both together, you get this reinforced concrete material that resists bending forces very well. So what are the cement water aggregate ratios? So what is cement? Yeah. Sure.
What is that?
Yeah.
Sand, water. Is that what you like?
No. I think you're about to describe concrete.
Cement is a part of the material, is a chemistry actually coming from the lands and it's a manufacturer. You can't make it yourself.
No. Yeah. You'd want to fair. What's that?
And have a 5 different types. Cement, just a cement.
Oh yeah. There are a bunch of different types. So I think I've got. What's that? What have we got? That's bright and light. Here we go. So now that one's sulfate resisting cement. So that's what I'd use if I was building a jetty, for example, which is going to be for where it's exposed to seawater, etc. But that's the cement powder, and we add the cement powder to water. Well, actually, no. Oh, so that's our cement powder. That's the grey powder that we're adding in. Okay, really easy one. What is water?
Hydrogen.
So it's water, right? You know, turn on the tap, you get some water. Great. So we know what cement, we know what water is. What's aggregate?
Rock.
Rock, yeah, rock. And we've got large aggregates and we've got fine aggregates. So sand is another form of aggregate. So that's just really tiny little rocks. So when we make up concrete, we add some cement, we add some water, we add some sand, and we add some 20 mil aggregate. So I say 20 mil because that's what your standard sort of N20 grade concrete uses. That, and then we mix it all together and we make concrete. Now, not all concrete is going to perform exactly the same. If I add too much water to my concrete mix will be weak. And it will be very sloppy as well. I get a huge slump. So if I put it in a cone, lift that cone up, and I've added too much water, it just goes like this. If I don't add enough water, well, if I add significantly less water, my concrete is going to be much stronger, but it's going to be hard to get into place, so it won't be easily worked. So we have different different ratios for different uses. If I'm setting up formwork like this and getting concrete into that formwork, and we've got really high lifts. So lifts, it means that, you know, this would be, you know, it's a 1200 lift, 2400 lift, so these are 1200 sheets. If I'm filling up the whole wall all at once, I'll want a really runny concrete mix. So a concrete mix with a high slump. So that's when when I tip it out, it goes like this. That's because I don't want air bubbles in there. I want it all to mix in. But I'll be sacrificing strength in that. If I am going to be casting these floors, I'll want much higher strength concrete, and I'll work that all down. So the golden rule for your concrete strength relates predominantly to your cement water ratios.
So would that be specified, say, I'm just thinking about the bomb shelter, the other place. It's going to have, well, the bricks are up waiting to be poured.
Yeah.
Okay? So, because of all the construction loads that have been wind, there's huge amounts of reo in that ready for concrete to go into.
Yeah.
That wouldn't be a ready cement, it'd be because it's going to have to be very strong.
Yes.
It would have to be, would there be some sort of value in the engineer's documentation to say this is this sort of cement?
Oh, definitely. Yeah. So the engineer is going to specify how that concrete is made, and then your concrete supplier and the people laying your concrete are going to work fairly closely together to ensure that that concrete is right. What you'll want to achieve, you'll want to achieve really thorough coverage of all your reinforcing, and you'll want all of that concrete to fill those sections clear, because you're going to strip away those form boards and you're going to see that wall, aren't you?
Oh no, that's brick.
Oh, that's right. Oh yeah, core field. Sorry.
So it's
Yeah.
But funnily enough, after this, I'm going to see a new engineer.
Yeah.
And I was wondering about that because some of that reo that's in there, we want to cut out and put some steps outside. And I know that's going to affect the structural integrity of the wall. So it's going to be one of the questions that's going to be asked about the concrete, because the concrete's going to get poured from the tilt down slabs onto Bondeck,
Yeah.
and then into the wall cavities. So it all bonds into that together.
Yeah.
I was curious about, you know, what sort of cement, because it wouldn't be the same, I would have thought, as the flooring cement.
So
It'd have to be different.
don't know. So you'd want a decent amount of workability in that concrete, because you've got to get it in a 90 mil cavity or so. 90 mil cavity with some 150 foot cavity. Okay, so there's a fair bit of space in there. So yeah, look, yeah, that's that is a question for the engineer. I would expect it's going to be the same stuff.
Yeah.
Yeah.
It's just one of those little mental notes I've got.
Yeah. So in that scenario, and I don't see that it needs to be super workable. Certainly you've got to do it in lifts, so you don't go blasting out. Oh, actually, core field, yeah, probably got. Actually, I'd have to say,
It would blast those bits apart.
Yeah, because you've got two separate leads of masonry happening. Yeah.
I mean,
So
he has, like I was gathering on Sunday, he has put ties probably every foot.
okay. Yeah.
Steel ties between
Very
each
true.
row
Yeah.
of bricks going across and tying that in.
Yeah.
All the way up.
Yeah.
That I could see.
Yeah.
So I thought, okay, well he's tied the two walls together, and then he's put the Rio up.
Yeah.
So I go there and then cut some more holes through it. I said, well, you can't cut through there. I said, well, I've got these big steps that I'm going to slide from one side through and to hold those in rather than having them ugliness on the outside. They're just going to float in thin air. And he's gone, well, you've got to talk to the engineer about how to do that.
Yeah. That'll be an interesting discussion with the engineer. I won't.
No,
but it may actually end up being the same concrete that's core filling as what you're using for your Bondec slabs there. But you do have different types of concrete for doing different things. Some of you, have you ever seen off-form concrete that looks like it's got timber look on the outside to it? So there's a whole bunch of that stuff that was done at Adelaide. It's done all over the place. So I don't know if there's anything around the TAFE here. So in one of my other classes, I've got a guy who's been a concreter and formwork maker for a very long time. Said at that Adelaide Oval development, that was the highest slump concrete he's ever seen for doing that. For getting into those timber look forms as well, because it's got to mould to all the fine details in that. Anyhow, so we've got different cement water ratios, and then you've also got different cement water aggregate ratios for different uses, for paths, for high strength concrete in warehouses, etc. So explore that. Have a look at that online. Also, what types of stone are available in South Australia? So this is something that we haven't covered in class. I don't think I've covered it. No, I haven't covered in class. So in South Australia, we've got a whole bunch of stone. Maybe I can mention that a little bit today. Question 5: plaster and plasterboard. Research a plasterboard supplier and find information about the different products they have and what purposes they're used for. Document your answer. So we haven't covered internal linings yet. Because this is due right at the end, some of these bits and pieces you'll be filling in later on as we go along. But I suggest do have a crack at putting together a OneNote and segmenting that into various different sections, putting your research into, and start collating this report early. So at the end, it's just about pulling it all together, tidying it up, and submitting. So that's that assignment. So I've got to quickly get back into here to get the slides up. So what we were covering last week was roofing, and we'll have to finish off roofing today, and then also get into masonry. So where we got up to last week in regards to our roofing, we're talking predominantly about sheeting, and we've got, for our sheeting, we've got different profiles. So that's our very traditional profile. This one, both of these are galvanised iron. So both it's got that large fleck in it. One's the traditional profile, which is a very high, it's 21mm, and it's a rounder radius. This one is 16 millimeters from flute, so from crest to valley, and not as round. So we've got all of our many different profiles. So
We did this last week.
yes, yeah,
You wouldn't believe it. The big piece of that.
yeah.
Is going to bring. I think it's going to bring it in, but I bought the good going.
Oh right, yeah, yeah. No, that's okay. So got some max now. And I can pass this around. So what I was going to show you, I've got these two. They're two different colours, but this shows how it locks together. So if I pass those two around, so one just pops on top of the other, and then underneath all of that, we've got these fixings that sit underneath that. So they get attached to your purlins, and then you just clip your sheeting on top of that. So having had a look at that, pass that one around as well. Yeah.
I think probably just stand up there.
What's that?
So we probably just stand up there.
Yeah. So our different profiles, etc., and different thicknesses. So we've got thicknesses 0.42 to 0.6 millimeter for roofing.
I've handled millions.
Yeah. Because we've got our different thicknesses and our different profiles, our purlin spacings, our required purlin spacings change. So it's a very important thing to understand is what purlin spacing you need to specify, because you need to specify those purlin spacings as per the sheeting that you're putting on. So purlin spacing usually 900 millimeter spacing for your ends and 1200 for the centers for your mid spans, but check with your product literature about your sheeting that you use, because something like this, it might be 1700 millimeters between purlins. You say to yourself,
I can get something interesting in that. You said we're going to have a break from Revolution.
yes, yeah, in a few weeks' time. Well,
Yeah.
after the break, yeah.
Yeah, because that's no good for cyclonic.
Right, because the fixings.
Yeah, because I was going to ask you about that, because even though we don't get cyclonic, M4 is just at the base of where cyclonic is.
Yeah.
Could you sort of then, as a safeguard, just put more purlins in? Because it's going to be those clips that retain it.
Yeah.
Isn't it? Or is it the fact that the sheets would come off from the clips? That's what I was going to ask you.
Yeah, that's a good question for them. I'd be interested to know you asked the question in the class. Maybe I'll brief and let them know that question. It's going to come up. That's a fairly engineering question, but yeah, but maybe it's something that they've covered before, and people have said, have looked into that and decreased purlin spacing for greater tightness. That would certainly make sense. And when we fix our roofing down, for roofing typically we're fixing in to the crest, so we do crest fixings, and we do it every second or third flute. So where we've got a join, we'll do one in the join, and then from that join we'll do the second one out, and then we miss two, so we do the third, and the third, and then the second, and then the crest, second, third, second, like that. Excuse me. So
the roof exactly we attach in the timber on the structure, or we use this on support.
That one you'll use onto the purlins.
yeah.
Okay, so that one will go straight onto the timber. Okay. The other one can go onto the purlins, or if it's a wide span, they have to put a timber on the purlins. Is that the question?
Yeah.
That's exactly structure.
Yes. So this. Yeah. So with our roof structure here, yes. Unfortunately, our roof structure doesn't have purlins attached to it. So purlins are bits of timber that go across this way, like that. So we've got our pieces of timber that go across this way, sit on top of there as well. So that's these things here. You can see those lines underneath there. So our purlins sit on there, and then our roof sheeting goes on top of those purlins, and the valleys face down to our gutter. And also, I spoke about scribing of ridge and hip capping last week as well. So this one, so here I've got a bit of scribed ridge capping. So that fits into the flutes of our sheeting really well. That is just a neater detail. So you can still you're not going to be like if you're very good with your scribing, I guess you can close it up to several millimeters. You'll still need to use some foam behind that or mineral fibre for building bushfire prone areas, but it's a neater detail than the unscribed capping. So just when you well, not when you're driving the car, but when someone else is driving and you're having a look around at houses, have a look. Some you'll see are scribed, some you'll see are unscribed. So we'll go quickly through our profiles. So we've got custom orb, that's the corrugated spandex. Well, I'll show you some diagrams of that in a minute. Clip lock. So underneath that one, that's pretty similar to our clip lock. So it's much like the Max line stuff, except our ribs are wider. And then long line, I don't have any long line here, but I can show you that in a minute on the slides. Actually, no, we don't have any long line in the table either. But long line's very similar to this Max line, but they're closer together. So this is the typical sort of table you'll get that gives you information on those different sheeting profiles. So your standard custom orb, that one there, standard custom orb, comes in 0.42 metal base thickness, 0.43, 0.48, and 0.42 and 0.48. These are your purlin spacings. So your 0.48, that'll get 1700 millimeters internal spacings between your purlins. 0.42 will only get 1200. Your ends for your 0.42, 900. Your 0.48, 1300. So it all depends on what thickness of metal, what profile. If we go like a 0.42 in clip lock, your end spans are 1700. Your mid spans are 2100 between your purlins. So that's maximum purlin spacing. You can space your purlins close together. When you've got profiles like this where all your fixings are concealed, it doesn't matter so much where your purlins go in a visual sense, as long as you keep them under your maximum spans, because you don't see any of those fixings. However, when you've got a product like this, where you'll see your fixings, where your fixings go through your sheet and you'll see them, then you really want to ensure that all your purlins are in a dead straight line and that they're evenly spaced throughout the roof. It makes it look much nicer because you see the fixings on the sheeting. Steel cladding available in long lengths. Typically it's one sheet to the gutter. With old houses you'll see that they're often two sheets, and you've got these joins midway. Has anybody seen that in old buildings? I don't know. But the reason for that is that.
These have long rolls.
Yeah, exactly. Yeah. So now you've just got this massive big coil of steel. It gets fed into a machine. It goes in flat, and then it comes out rolled like that, and it's spat out in this way. So that piece of sheet can be as long as you want it to be. You know, the main limiting factor is how you're going to transport that to site.
There's a house on the ground floor on the Ross. That was one of Max Pritchard's ones.
Yeah.
And I'm not too sure whether Revolution did it or not. No, they didn't.
No, I think it was.
It was a custom
I think it was
roll
Fielders.
no, it wasn't.
Was it Fielders?
Just remember, I've got the place.
Yeah.
He's up to Bronson. And he got a custom roll there because it was 150 metre length.
Yeah.
Like, just rolled, and as they were rolling it, they were taking it up on the roof and taking the sheets down the roof.
Yeah.
It was amazing to watch.
Yeah. Yeah. Yeah.
Just wind. Yeah, it's funny.
Yep. Yeah. So your typical transportable lengths are 15 metres long. Beyond 15 metres, or you can go to 18 metres. But then beyond that, then your portable roll form is probably the best way to go about sheeting up really long sheets. Yeah, I tend to think it's a good idea to stay away from. Like it's something you're going to weigh up, but yeah, I've seen some other projects where they've specified really long sheets, and it's just been really problematic. It can be problematic, and it's not cheap to get a portable roll former out and roll sheets up. And
that stuff there over. So you corrugated your holding in your hand if it's cut on.
yeah,
Okay. On a roof, about $12,000. Okay. Go to that stuff there.
yeah,
Custom roll for me. Okay. 55,000.
yeah,
That's the difference.
Yeah.
Same roof.
yeah,
Size, but custom rolled.
yeah,
Cost me 55.
yeah, and so 12,000 bucks. Roll former on site 55,000, and then roll former not on site probably around the 25. Is that? Did you? If you do it in 15 metre lengths, what's that?
You got to do more on site.
Yeah.
So I didn't get
Yeah.
it
So you didn't
on
go that. Yeah. So typically this costs you about twice as much to install as this.
How come it's so much?
Because this one is thicker. It's also
They just charge that in the mat, because I'm in that colour, I'm custom made, so I need a specific width, okay? They have to bring the machine across from WA, so
Right.
wait until
okay. Yeah.
it comes over, and B, because it's only a limited run of material, okay, and there's going to be, unlike your corrugated iron, you've got a roll of corrugated iron, you're rolling the whole roll, okay? When you roll that, unless you go in their specific widths, you've got wastage, okay? So they might only get that pan, they might get, if they're lucky, 2 of those out of the roll width, okay?
Yeah.
In mine, you're only going to get 1 out of the width. So they might say, okay, well, with that big roll of steel, you're going to have 2 of those to get the same. So they charge me for that.
Yeah. And also they can, if so there's the whole thing about wastage and also in doing a custom product, but also if they're not doing much of this, right? They have to get that roll former going. They have to feed that coil of steel into that. That all takes time. So Revolution, for example, I think on Tuesdays they're doing the galv, because I've used galv recently. I think it was on Tuesdays that they roll it. They put their big coil in and they just keep rolling, and they're just like, okay, we want 10 sheets at 5.4, and then they're spitting out chop, chop, chop like this, and then 5 and 6/3, whatever, and the machine just keeps doing it, keeps producing it. When they're finished with that, they've got to take that coil off, go pick it up with the forklift, go park it somewhere else, get another coil on, set the machine up for doing some other stuff. It's most efficient for them to be doing stuff which is really common. So the stuff that happens really often, they can produce a whole lot of that without that stop-start interruption. When you're doing something which, you know, they'll do that, you know, maybe once a month or something like that. Yeah, you got to pay for that because it's more stop-start and more mucking around. But it's also a thicker sheet, so you need to have thicker material for doing that. And yeah, and there's, you know, and possibly some wastage in that as well. So available in long lengths, usually one sheet, ridge to gutter. Oh, that's right. I was going to say. So the reason with your really old houses that they have several sheets before the gutter is because they used to roll them this way instead. So it used to be feeding the metal in this way, and then have these rollers that drop down and do it like that. Now it goes the other way, so it can be continuous. Yeah. I'll keep moving on from that. Important thing to think about with your roof sheeting is solar radiation. So with your really dark colours, it absorbs heat. It's not reflecting the heat back out to the atmosphere, so that's bringing heat into your building. In summertime, that's an issue. So because dark colours absorb and bright surfaces reflect, those dark colours are going to have more insulation under them. Yeah, it can be plain or organic pre-finished zinc aluminum. So that's actually I can't think of what the material is. Oh, okay. Silicon modified polyester is Colorbond, and also acrylic and PVC films available and suited to marine applications. Also, you can also, and you certainly have to pay for it, is you get stainless steel sheeting that gets Colorbond coated as well. So yeah, not cheap.
I'd rather just go and buy copper.
Possibly, yeah. So usually delivered to site in strapped bundles. So the truck will go around and it's got a whole bunch of roofing. So for you doing a hip roof like this, you order, you know, a whole bunch of sheets that are this length, and then then your shorter lengths for forming up your hips, the ones that get cut. So you'll say these are the sheets I want. You specify them. They produce them all automatically, bundle them up, strap them, and then they go out and they'll get delivered at the same time as, you know, 10 other deliveries or so. And then they'll just hire those strapped bundles off and drop them on site. When they get dropped on site, they should get put on bearers to pick them up off the ground. The reason for that is if they go sitting on the ground, they can get moisture in there, and you want to avoid getting moisture in between all of your sheets because it can mark your Colorbond. So areas close to the seam, marine areas, seek specialised advice. So stainless steel can be used in those scenarios. Handling sheets with gloves preserve the finish. If you're working with sheet metal, like yes, I'm grabbing all this sheet metal and I'm showing it to you and passing it around, but working with it on site, you should always wear gloves anyhow. Avoid sliding sheets over other surfaces. So yeah, your big sheets that get very cumbersome, they start sagging in the middle. If you go picking those up and dragging them along, you can scratch the Colorbond finish. Well, Colorbond scratches really easily when it's new, and also you can scratch the zinc aluminum finish, which means that the sheets will corrode in that point. And don't drag tools over or drag them over abrasive surfaces. Also, don't use an angle grinder for cutting your sheets. So there's plenty of really good tools now for cutting sheets. Yeah, super shears, that sort of thing, that don't heat up the metal. If you go heating up the metal, then then that's a really good entry point for rust. You'll start rusting that really quickly. Yeah, so we've got two different fixing methods: screwing, so directly through the top of the flutes, or concealed fixings. All cutting, bending, and fixing is to be in accordance with the manufacturer's specifications. With thinking about weather and thinking about predominant wind directions, or for when you're lapping your sheets. If, for example, with my roof here, my predominant wind direction is this way. So from the south, we'll get winds from the south. I will start sheeting on this side, and I'll lay them this side like that, because the second sheet that I lay, that flute is going to face this way, so that my wind blown rain in wintertime is heading that way, rather than if I was to lay my sheets starting that way and go this way, because then that wind blown rain gets blown under that end of the sheet if it starts to lift up a little bit. So you've got to think about, or roofers have to think about, the predominant wind direction, but sometimes it's good for designers to be considering that as well. Doug, you've got a smile on your face. What was the...
I've just seen too many just drum on. And you see the oxidisation when they've done that, like pulled a few roofs or something.
I've seen it where somebody laid sheets over a long skillion roof, laid the top ones first, and then the bottom ones. Can anybody think of what the issue with that is? Besides Doug.
Wouldn't the air get trapped in them instead of having it this way?
Yeah, exactly. Yeah. So the water's going to run down here, and then it's going to run straight under that sheet, and it was Anyhow, so I went in this house, and there's this line across the ceiling in this room that's been an extension. I was like, what's causing the water damage? And then went up on the roof, and the sheets had been lapped the wrong way. So you've got to think about those side laps, which way you're facing. You've got to think about the end laps. Also, the sheets right at the end, you have to turn the valleys up. And then also, in some scenarios, it's good to lip the valleys down into your gutters as well. So I think we've got, so that's turning up your end laps. So done with an adjustable spanner or a pair of pliers, and then you can lip them down into your gutters as well. So I don't have any here, unfortunately. Actually, I think we do. I think we do in the storeroom. Maybe I'll go grab some soon. Insulated roof panels. So it's what this whole building is covered in. It's it's not corrugated iron. I'll go grab some actually.
So corrugated iron, you pretend that is a foam. So you'll see, what do they call it, cool roof?
Yeah, they call it all sorts of things because all sorts of people
so
building.
Imagine that there is actually a big, thick sheet of foam, and that's adhered to that tin.
Yeah,
that's what you're talking about.
That is what I'm talking about. Actually, I'll just go grab some. I'll be not very long at all.
this was utilised?
So this is some roofing that incorporates insulation in the roofing. I'll pass that one around.
Yeah.
And that's a section through the walling. So what's that?
I know it.
You know this one?
Yeah, I love it.
Love it, yeah. Yeah. It's a fantastic material, so that way you can span really long distances between supports because that insulation in the middle is part of the structure.
What they call?
So these are structurally insulated panels. So the insulation forms part of the structure. The difficulty, how do I say it, the limit to the application of that stuff for roofs is that with the National Construction Code for, say, Climate Zone 5, where we are here down on the flat, you need to have at least a 4.1 R value for your roof insulation. And then Climate Zone 5 in the hills, at least 5.1 R value for your roof insulation. This only achieves R 2.5. That's all. Yeah, it's a bit yeah.
Interesting.
I know it is a bit odd. Like the thing is, yes, we've got this R value, and the way that R values are tested is, they apply a heat source and they measure how much heat comes through there at this point. The thing about this stuff is that it's continuous insulation, though. For example, if we've got a wall, we've got our stud walls and we've got our insulation in between all the studs. Where our studs are, that piece of wall is not insulated at all, and you've got these materials that connect together, and heat gets transferred in and out. Still, the way that it's assessed is that portion that has the insulation is assessed. So that's for that wall they'll get R 2.5 or so. Whereas with this stuff, your insulation is continuous. So yes, it might only be 2.5, but nowhere along that wall is there any thermal conductivity. So although it's only 2.5, it actually performs really well. And that's it's an issue with the National Construction Code way testing is carried out, etc. But that limitation, the fact that that's only R 2.5, means you can't just go, all right, yeah, let's use SIPs for a roof on its own in a residential application. You'll still need to batten that out, and you'll still need to provide insulation on the underside of that to bring it up to 4.1 or 5.1 or so. So you've got additional expenses involved in that, and so this ends up just becoming too expensive to do for roofs. I think it's unfortunate, but that's yeah.
I mean, we didn't, because we've got such a large roof. That's why we didn't look at it. That's why it's getting the base chance.
Yeah. So it's fantastic in an application like this, where it's a commercial application, and this building is, all this work is engineered, etc. All the architects and engineers involved, and they do it rather than the deemed to satisfy method through the National Construction Code. It's all performance requirements, and okay, they say yes, the building meets the performance requirements, etc. There we go. So fantastic for these sort of applications, and for cool rooms and things like that, and fantastic for a walling panel, but it has its limitations for use in roofs, unfortunately. Also, with your roofs, you're going to have to have flashings. So our ridge capping here, that's a form of flashing. So that's not part of our main bit of sheet. That's a piece of sheet which goes on top to help form a weather seal. But we have flashings in other parts of the roof as well. Our valley gutters, when we've got two roofs coming together, a valley gutter in there, that's also a type of flashing. So flashings are any of these little bits of metal which are all bent up to help direct water to one place, also to keep mice rats, birds, possums, etc. out, to stop water blowing into the roof. With your flashings, they have to be compatible with your roof sheeting. So I think I've explained this before, when you've got two different types of metal together, one type of metal will be, yeah, that's right, I explained it in regards to galvanizing. So one type of metal is going to be more reactive than the other. With our galvanized sheeting, that zinc is more reactive than the steel, so the zinc does the oxidizing, takes the free electrons from the steel. When we join flashings together and put flashings onto roofs, those materials have to be compatible as well. We don't want to use flashings that are significantly different in their reactivity, because otherwise you'll get one piece of metal rusting and working as a sacrificial anode. However, it's not too much of a consideration now, because a lot of your flashings are these materials made specifically. Well, you've got flashings made of exactly the same material as the rest of your roof, or you've got these flashing products that are bitumenized with a piece of aluminium inside there, and you've got your you don't have the conductivity between that aluminium and the steel of your roof as well. So a lot of your flashing products are designed to be compatible now. But yeah, it's what I was talking about there, with some metals more reactive than the others. That's the galvanic scale, and I suggest you go have a look at the galvanic scale, see what that is, see how that works. With tiles, we don't really need to worry about the galvanic scale. Tiles produced. This one's a concrete tile, so yeah, same, very similar sort of materials as to your concrete elsewhere, but there's a whole, and you probably would have noticed when I passed around that tile how much heavier that is than the piece of roof sheeting you're passing around. With your tiles, you're dealing typically with about 90 kilograms per square metre on your roof, as opposed to between 10 and 20 kilograms per square metre with your roof sheeting. You've got, I don't have any here, terracotta tiles, which are a natural clay that's fired. Concrete tiles like that one, slate tiles, also slate shingles. Fibre cement shingles, not that you see them very often. There are some buildings still have asbestos fibre cement shingles. Yeah, I looked at a place for sale fairly recently that the whole roof was all asbestos tiles. Timber shingles and shakes. So can't remember the difference between shingles and shakes. Durable timber. So split into shakes or sawn into shingles. So cut with a saw neatly. It's cut. So I live in a very old house. When I go on the roof, it's all timber shingles inside the roof. So that was back in the very early days of settlement here. However, that's all been covered with galvanised iron. And so you'll see there are still a few buildings around Adelaide, etc., that have timber shingles for the roof, but you'd never know because they're all covered in galvanised iron. But some people also use it in a modern context as well. Metal tiles. Has anybody ever seen metal tiles before? Anybody apart from Doug? Seen metal tiles before? I'm thinking that you probably have. Sometimes they're not that easy to discern or to spot the difference between your metal tiles and your terracotta tiles. Look, you get metal tiles on roofs that have this texture coating finish, like they spray like sand on the outside of them. They look a lot like tiles. In my opinion, they're actually a fairly shocking product.
It's heavy.
No, they're actually really light. They're really lightweight. Now, this is a modern approach to them, and I guess possibly they're not so bad. But what happens with these metal tiles is that they're really soft, And if somebody's working on the roof, they have to step only on the joints. So you have to go and you're stepping on the joints to get up somewhere. If you step in between one of these joints, they buckle like that. They pop like that, and then you end up getting water in your roof. They're just, yeah. So often, and this goes back to the galvanic scale as well, you've had situations whereby you've got these aluminium tiles fit, you've got old galvanised iron roofs. Someone goes, okay, let's update the look of this place, and they put imitation tiles on top. They're aluminium. And then those two different metals working together rusts out your roof. So you get water coming in, and then you get your roof rusting as well. It's a fairly bad situation. So it's something that you don't see a lot of because they have been fairly problematic.
There's a new tile too to the market. It's a plastic.
Right. It's like a PVC, is it?
Are
you PVC?
Not sure when I was investigating the solar panels, a company in Sydney does a solar panel tile.
Oh yes. Yeah.
But it's a plastic glass arrangement.
Yeah.
Trying to think which they sent me some guff on it. And they did a cert on somewhere in Sydney. And the roof, it's just multicoloured with these tiles.
Oh yes. Yeah.
So they can change obviously the picture in the tile colour.
Yeah. Yeah.
I don't know what its durability is going to be like. It was worth it.
Yeah.
Plastic roof.
Yeah. I might have to have a look at that and update these slides as well. We'll often with these new products, you don't know what their durability is like, and you've got to let some other people test them for a bit first. When you use tiles, you've got to have sarking underneath. So that's the reflective foil. It's just a thin. It's a material used to wrap buildings. So when you build a building, you use this sarking. You wrap the whole timber frame in it. When you're doing tiles, well, actually, when you do any sheeting, you should put sarking underneath anyhow. But tiles, you have to have sarking underneath. Tiles can be mechanically fixed, nails, screws, and clips. I've done a bit of work so I was installing solar panels on roofs, lifting up tiles. What I'd often notice in that is you've got tiles that are wired down. You have a whole series of tiles wired down, and then you have one that's screwed, and then a whole series that are wired and then screwed, etc. A lot of people laying tiles use a combination. May use a combination. Fixings are galvanised. Previous systems were tied with wire. Fixing type does differ between the tiles. So that one's got. Actually, I'm not sure if that's a nail hole all the way through. No, that one's not a nail hole all the way through. This one should be wire tied. That one, but some tiles you get, they have nailed holes through, so they're to be nailed into the battens. Roof pitch influences the fixing methods, so steep pitches 40 to 70 degrees must be mechanically fixed. This is your unit mass of your various different materials. So I was saying that your roof load or your roof weights for your tiles around the 90 kilograms per square meter. This gives the mass of those tiles, but then underneath all your tiles you need a lot more timber, etc. So you've got timber battens at 300 centres, and then your rafters at 600 centres. So the whole thing added all up gives you more weight. So our steel roofing, 4.9 kilograms for the sheeting alone, and then you've got your associated structure underneath. roof gutters. So I showed you some various profiles of roof gutters last week. You need to have, we've got, fall must be towards the downpipe. So gutters installed to fall towards downpipe at minimum 1 is to 500, but you can increase those falls. So minimum is 1 is to 500. Or position downpipe at each end or 12 meters apart. I think that 12 meters is now 10 meters maximum spacing between your downpipes. Fixing brackets at 1 meter centers for high wind areas and closest for high wind areas, closest spacings are required, but that can also differ between your manufacturers. So if you're using a certain type of gutter, your manufacturer may specify closer fixings for your gutter supports. This, not that you can really see it, this gutter is a slotted gutter. That slotted gutter means that water can actually flow out the side of this gutter if the downpipes get blocked. So our gutters, the edge of the gutter carries up higher than your roof sheeting, because what you don't want to see when you're standing at the street looking at the house is to see your roof sheeting up higher than your gutter. It looks very messy. So the edge of your gutter carries up higher than your roof sheeting, but that is an issue for if that gutter fills up with water, then you can get water into your eaves. Yeah, and you've got various different coatings on there. So Gal, zinc, and Colorbond. A whole host of different profiles. That's your standard gutter, your quad gutter, and that's what you'll see. That's what you see a lot of. Box gutters, very handy thing for designers, so they enable some fantastic stuff to be happening. But box gutters should be designed, how to say it, fairly conservatively, because when a box gutter overflows, it can cause a lot of damage. If it overflows into a building, it can cause a great deal of damage. And box gutters are problematic. They're known for being problematic, so you they have to be designed well. There is an Australian standard for designing box gutters. However, there's also a thing called the online box gutter calculator, which is actually a really handy tool that has summarised that Australian standard into an online calculator, so you can punch in all your information and it can tell you the size of your box gutter required. The crux of it is that, so you have rainfall intensity. Your rainfall intensity differs around the country. So if I do a box gutter in Adelaide or I do one in Cairns, there's going to be a difference in rainfall intensity between Adelaide and Cairns. My box gutter in Cairns is going to have to be much bigger than my box gutter in Adelaide. But even from Adelaide through to Victor Harbour, there's going to be a difference in rainfall intensity. So this Australian standard includes the calculation of rainfall intensity for your various different locations. But the box gutter calculator makes that much simpler. You just punch in your postcode and you get your rainfall intensity. And then you punch in your various different information. You get your box gutter size, your downpipe spacing, your box gutter slope, etc. Also, so we have our rainfall intensity. Then we have to look at the amount of roof area that's feeding into the box gutter. Then we have to calculate our slope on the box gutter, and the slope, we can have limitations on that slope, because that slope, say this box gutter here, there's a really long run of that box gutter. The issue when you've got a really long run of a box gutter and you've got to provide slope, if you've got to do a 1 in 200 fall on that box gutter, that means that what's that? 1 in 200 is trying to think of how it. So 1 minute.
It's 1 minute is long. You're going to have 1 metre of height.
Yeah. So if it's 20 meters long, you've got 100 millimeters of fall from one end to the other. 100 millimeters is a decent amount space when you're talking about a roof. So, or then if you've got your box gutter that's 10 meters long, which is a very short box gutter, you've still got 50 millimeters of fall from one end to the other. If you've got a box gutter which is already 300 millimeters deep, and you've got to add another 50 millimeters onto that, then your purlins have to be up at least that 350 millimeters off your structure that carries in underneath your box gutter. So, and you'll, hopefully in commercial construction you'll get into the design of box gutters more, but understand the design. It's fairly limiting. So, and you have to design them very conservatively. With your downpipe, with your downpipes that go from one roof onto another, there needs to be a spreader at the end. That distributes the water over a larger area to a gutter. If we had just this downpipe going onto this roof without a spreader, we'd get a torrent of water heading just down one flute and then going straight over top of the gutter. Also, and I mentioned that online box gutter calculator, you can use that same online box gutter calculator for calculating eaves gutters and for calculating downpipe sizes as well. Your downpipe sizes will be different depending on the amount of water which is feeding in to that gutter. And yeah, we'll move on. So here's some examples of flashing. So that's a ridge capping. That one's been scribed into our sheeting to fit nicely. This one's a parapet flashing. A parapet is where we have a wall that extends past our roof sheeting. So that flashing is fixed onto the wall, and then we have a flashing built into the wall that folds over the top. With our flashings, we always have to think about lapping away from the direction that the water is travelling. So, so if the water is travelling down this way, we start installing our first thing of flashing at the bottom, and then our next thing of flashing goes over the top, just to ensure that, does that make sense to everybody? How?
What if you get, sorry,
Yeah, it's all right.
there's so many things I want to ask.
Yeah.
That's in a brick situation, so I'm using the cable. Okay, I'm not going to be able to put that under a brick course.
Yeah.
And I'm not having a capped parapet. The parapets are actually the render type stuff.
Yeah.
Comes as a
Yeah. Okay.
that makes it capless.
Can you have a joint? So with your Hebel you're using power panels, so like 50 or 70 mil thick, 75. Can you have a break in that Hebel? So you got your stud work. I'll draw it.
I'm just thinking at the top line of
Yep.
the roof,
Yep.
because at the top line of the roof it basically comes up at the top.
Mm-hmm.
I was wondering whether you could effectively in your second detail there, see how you've got the flashing into the actual wall.
Oh, this one here. Yeah.
No. That's
No.
what you're pointing
Oh,
out.
yes, okay, yeah.
There. Could you do that? Could you like grind into it and put that in like that, or not? And seal it in there.
I've got issues with how well that'll fix in there.
So,
A detail.
that's something I'm
Now,
trying to get my head around.
Yeah. Okay. So just off the top of my head, this is the sort of detail I prefer in that regard. So this is our stud framing here like this, and then we've got our top hats for fixing our Hebel to, etc., and that's carried down further here. So then we've got Hebel sheet there.
Yeah.
I think it's better to actually have a break in your Hebel sheets, and so you have another Hebel sheet here, like that. So we've got our break in the Hebel sheets, and then you've got flashing fixed back to your timber frame inside. So you're flashing, and then this is your parapet here. That's your parapet. You're not capped. Your parapet doesn't.
The Hebel will go from one side over. to where the roof is, so that'll be the exposed seat
Yep.
side.
Yep.
That's heavable. It basically will be that panel of hevel come across and back down.
Yes.
Will only come down to effectively.
Yeah.
That
So
cap.
yeah, and you're yeah.
So you're saying.
So I'm saying rather than have hevel that goes all the way up, and you notch in and you're cutting in, I think it's better to actually have a hevel joint there and carry your flashing inside. To fit, because if you're just notching into your hevel, then you're relying on that mastic sealant to bind with your hevel and your flashing. Stuff doesn't bind to hevel all that well. Now there's certain hevel adhesives and possibly CSR or hevel have details in regards to that. So, and certainly if they've got details, use their details.
Yeah, I've got the details on that, but they like having aluminium, ridge capping.
Yeah.
Look, I just hate the look of it. And
yeah, so you've gone.
The architect sent me. He said, "Oh, you're going to be using this render product. They make effectively a
formed.
That goes over and you render it.
Yeah.
Use that." And I went, "Oh, beautiful."
Yeah. So if you've got a form that goes over the top, to the extent that form carries down, I'd carry your flashing inside. Inside, and then have it. Certainly, that flashing has to have a slope toward the outside, so our water has to go toward the outside, and then it's carried in here. And depending on your distance there, look, I think a flashing over the top of that is also a good idea. Look, that's completely up to your architect to design that, but that's the sort of detail that I'd feel far more comfortable about, because that way your flashing is fixed really well, and all your surfaces are sloping down, facing back to your roof sheet. What's that?
So I'm redrawing all the detail for the moment. So.
Yeah. So, but you've got an architect working on it as well?
No, I had him do. All I had him do was basically, I drew the place.
Yeah.
But I wanted it to have architecturally so I just gave him my drawings and said,
yeah.
Put your name on it, draw it, so I can get it through council.
Yeah.
And that's the end of his involvement.
Right. Okay.
So I mean, we talk, but he's not actually now involved in it at all.
Yeah.
I'm doing the redraw, and he's going, because of the cement, he's going to sign off on that. And I've had it recertified.
Yeah.
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 Little intricacy things like this, I'm doing all the detail.
Yeah. Yeah. So beware that you'll end up being the one responsible for those.
Yeah. Well, that's this way. Nah. It's going to get all checked off. Don't worry.
Yeah. But yeah, if you can have your flashing securely fixed and all facing away from making water flow by gravity, it's your better details. So what we have is we've got our parapet gutter that goes in first. Parapet gutter, box gutter, they do get used interchangeably, but yeah, correct terminology, parapet gutter in here, and then our flashing lips over top of that gutter. So lap away from weather direction I was talking about earlier on with your laying your roof sheets on. That's what that refers to. Dissimilar metals, so that's your galvanic scale, and that's it for roofing. So there's a bunch of websites here, a bunch of links for you to check out. Now, by no means is this, how to say it, comprehensive. There are so many people providing various different roofing products, etc. These are just a couple. Also, quickly today, but we'll finish it off when you return. We'll have a quick introduction to masonry as well before you guys head off onto the brake. Now is this right? So just down here, just before the class started, I added this, the M&Dipweek coursing chart. With your bricks, it is really important, if nothing else, to know the standard size of a standard brick. The reason for, and this is not a standard brick by the way, this is a cross section through a Besser block. And talking about Hebel, that's Besser Hebel. I'll pass that one around. Yeah, you expect it to be heavy, and then it's like, oh, yeah, nice. This one is a standard brick. Yeah, wow, surprising. So your standard brick, it is 230 long, 76 millimeters high, 110 millimeters wide. That 230, 76, 110 is a very important number to remember. The reason that 230, 110, 76 or 230, 76, 110 is a very important number to remember is because that dimension ends up carrying through your building so much. If we thanks. If we have a quick look at this coursing chart, now you'll see up here there's standard brick and modular brick. So I passed around that standard brick. I'll see if I can quickly find a modular brick in here. We've got two different charts happening. Oh, there's a modular brick. What's that?
I'll bring you one of mine.
Right, yeah.
It's actually smaller than that.
Oh, right, okay, yeah. So we do. Yeah. So we do have different sizes of bricks. Well, those modular bricks, 390 long, and they didn't put a height on there, so we've got two of them at 200, so that means they're 190 high. But the thing is, your modular brick, well, these ones are longer than your standard brick, or you've got modular bricks and metric bricks. Maybe possibly this one's a metric. But you have different sizes of bricks. However, predominantly all the bricks you see are standard size bricks. These 231, 10, 76. That ends up having an influence on your window sizes. It has an influence on your plasterboard sizes, your stud spacings, everything. The reason for that is bricklayers don't like cutting bricks. If they want to be cutting bricks, they'll be cutting them in half. As you lay bricks in a wall, typically you lay them in a stretcher bond fashion like that. So there's one here, then you have a joint, and they're laid like that. Has everybody seen that stretcher bond fashion in the way that the bricks are laid in a wall? That means that when you get to a window, you'll have a half brick. Or you'll have a whole brick and a half brick, whole brick, half brick, whole brick, half brick. That means that when the bricklayer chops this one in half, they can use that other half on the other side. What they don't want to be doing is chopping it into thirds or 5/8 or some odd increment, because then they've got these little bits and pieces left over. They want them whole bricks or half bricks. Then and so we end up having openings of our opening of 610, then an opening of 1210 and 1810. So that's 600 millimeters plus a 10 millimeter mortar gap, 1200 millimeters plus a 10 millimeter mortar gap, 1800 plus a 10 millimeter mortar gap. Also, if we look at our height of bricks, we have a lot of figures that are also in those increments of 300 millimeters. So we've got got 600 here, and as we go down, we'll get further down 1200 millimeters, 1800 millimeters, etc., etc. So there's a lot of commonality between the dimensions we end up having with our standard size bricks and the dimensions of all your materials. So can anybody think of like the standard size of a plasterboard sheet? Well, actually, we know there's a few different sizes now as ceilings have gotten taller, but you know, we've got 1200 by 2400, and a lot of your building products are in those.
Normally around 1200 is most of your building widths, like plasterboard or plywood.
Yeah.
And working back to your carpets, even if you get carpets on the floor, will be 3600 as well.
Yeah.
So that's sort of the maximum size I think a domestic bedroom or room is going to be.
Yeah.
1200.
Yep. Yeah. Yep. So all these increments of 300 millimeters. So you'll see these increments of 300 millimeters popping up in buildings all the time. That relates back to your standard bricks. Also, when I was doing detailing for a lot of repairs of buildings, I had to do detailing from a lot of photographs. So engineers would go measure stuff on site, but then a great deal of measurements they didn't take. I'd have to look at walls and count the bricks. You go, okay, that's how high that wall is, or that's how long this run of wall is, because you can count your bricks and go, oh, I've got 18 bricks, that wall is 4.3 meters long, or that opening is 4.33 meters wide. Also, so that's how brickwork dimensions relate to a house. When we're designing houses, we also have to be very cognizant of those brickwork dimensions. If we're designing a house that's going to be clad in brick veneer, we also want to ensure that where we place our windows relates to those brickwork dimensions. So we'll want our walls to be, you know, that 4.31 long before we have a window, and then you've got your standard size doors and windows, and you design your location of all these doors and windows as per your brickwork dimensioning. If you don't, then you have very unhappy brickwork layers, because they'll be laying those bricks, and then they'll have to be cutting small bricks. It also looks really bad. Many of these things that, how do I say it, are intuitive. When you look at buildings, you know, we're just used to seeing bricks as whole bricks or half bricks, not little thirds of a brick or so. Bricklayers can also sort of stretch things out a little bit. So you've got your mortar joints happening. So you've got mortar joints happening between your bricks. Now typically they're 10 millimeters. That's 10 millimeters is your distance, but the bricklayer might stretch those out to be, you know, 12 millimeters or 13 millimeters, getting a couple millimeters for every brick, enabling them to meet the location of your windows. They're not very happy about that either, but that can be done. The best thing to do is design your buildings with those brickwork dimensions in mind and place your windows accordingly. So that chart is up there, and that's free. Well, free for you to use. So grab that, put it in your OneNote, for example. Oh yeah, here we go. So a bunch of resources here for you as well to refer to in compiling your research for your projects. Yeah, and basically we'll start right at the start again with these masonry slides when we get back in. But I'll just give you a bit of an introduction to them. Masonry as a term that relates to the bonding together of individual units. So masonry can be bricks or it can be stone. In South Australia, we've got a whole lot of natural stone which is available. Can anybody think of natural stone that we've got in South Australia that you've seen or that you know of?
Limestone.
Yeah, got lots of limestone. Yeah. So limestone, yes, you've got it used in a lot of older buildings and a lot of, how to say it, external stone walling. So walling in gardens and things like that. You don't see it used much, if at all, in modern buildings, except for Mount Gambier limestone. If you head down to sort of Keith, border town, and from there on, you'll start to see some buildings that have what look like concrete blocks, but they're really big. That's just sawn sections of limestone from Mount Gambier where they've cut into the ground, they just run a big saw through there and they cut out these big limestone blocks and use that limestone block for walling. Any other forms of stone we've got here in South Australia in abundance? Anyone? Bluestone, yeah. So, anybody heard of a place called Kanmantoo? Yeah, it sounds fictional. No, it's just...
Best restaurant in South Australia.
Yes. Strange little town. Anyhow, yeah, so it's right out, it's out there, so there's a town called Callington if you're driving to Murray Bridge, just 3/4 of the way there, little town called Callington. Just in from there is a place called Kanmantoo where they mine bluestone. There's also, what's happened now is the Kanmantoo mine, so not the bluestone mine, or not the bluestone quarry, but the mine where they're extracting all sorts of metals and whatever. It's becoming a huge, it's a massive project now. So just in there they've got bluestone. Trying to think who else does bluestone in SA.
Wasn't there one up the back of Norton Summit for doing the bluestone?
Possibly, because you've got bluestone there.
Bluestone there, and then there was slate.
Yeah.
Slate quarries down south.
Yeah. So yeah, slate very similar to bluestone. Slate splits into sections, thin sections. So places famous for their slate in South Australia, you've got Wollonga, so Wollonga slate, and you've also got Mintero slate. Mintero slate is a very high quality slate. So Mintero, that's out near the Clare Valley. Wollonga, that's down south, McLaren Vale region. So they're mining slate at Wollonga and mining slate at Mintero. Slate is often used for, this is not slate by the way, but it's used for stacked stone walling. That's where you've got small, thin layers of stonework, and it's all stacked together. You've also got Carey Gully and Basket. What's that?
Carey Gully sandstone.
Yeah, so Carey Gully sandstone and Basket Range sandstone as well. I'll quickly bring up a Basket Range fronted sandstone house because I'm fairly sure it's one of those things that when you see it, you go, oh yes, I know, I've seen plenty of buildings like that. So there we go, an Adelaide suburban classic. Has anybody seen any buildings like that before? Yeah. So that is sandstone mined out of Basket Range. You can see that that's Basket Range sandstone because it has so much variability in colour. You've also got Carey Gully sandstone, which is predominantly these orange colours, so orange and peachy, but it doesn't vary so much in your colour as the Basket Range sandstone. So Basket Range, if you head up the hills, sort of take Green Hill Road up, you'll hit Summertown, Urayla, a bit further on, then you'll hit Basket Range after that. That's where this stone comes from. If you drive through Basket Range, actually, what's first? Oh no, Carey Gully's like to one side, Basket Range. Yeah, Basket Range sort of a bit more to your north, Carey Gully a little bit more to your south from each other. But they're both very close together. At Carey Gully, they mine a lot of sandstone there as well. Can anybody, well, everybody's been down North Terrace in Adelaide, right? And you think of all the the big stone buildings on North Terrace.
Courts.
Yeah, so you've got government house, yeah, you've got the universities, etc.
Central Market, that big building there.
Yes,
That's
yeah, yeah. So a lot of those early big institutional buildings, they're made out of sandstone as well. You don't have nearly this colour variation in those. They're very uniform colour. A lot of that is from Mitcham. So sandstone mined in Mitcham. I don't know if Mitcham, if you can still get sandstone out of any areas in Mitcham now. I don't. Quarry operations are very noisy, very dusty areas. You've also got some granite mining in South Australia as well.
the one behind, up the top of McGill Road, you go and start rolling up to North and Southern, there's a massive mine.
Yeah.
Back in the hill. Is that correct?
I don't know. Yeah, yeah. What's that one? Gandy's Gully, I think it's called, isn't it? Gandy's Gully mine.
Actually,
or
you go
quarry.
into the mine, there's a back road that goes up to the sky.
Yeah. So that's owned by Boral, that one, but I don't know what they call it. So there are also a lot of quarries about the place. You've got one at Sellex Hill. You've got one just off Gorge Road, yeah, where they mine basically just for aggregate, for concrete as well. So that they might be bluestone also. There are various different types of stone suitable for aggregates as well. But yeah, you also got the granite mined. So granite gets used in bench tops and things like that. Trying to think of other stones. I think we've pretty much covered it for stones in South Australia that are used in construction. So we've got bricks, we've got stone, and then we've also got concrete blocks as well used in construction. So that's something Doug will probably be fairly familiar with. Yeah, for your core-field masonry. This stuff, so I've referred to that as core-field masonry. Well, there's several ways of doing it, but with these Besser blocks, so they're called, well, they're concrete blocks, but Besser Monia Besser is a company, and so typically in South Australia they've been called Besser blocks. You'll notice they've got two cavities in here. They're also stacked in a stretcher bond fashion, so you have one here like this and then one midway. That means that all your cavities end up lining up. Because those cavities line up, when you lay those Besser blocks in that fashion, you can run reinforcing vertically up these cavities and then fill it all with concrete. So you can use this concrete as a formwork that ends up becoming part of your wall. And that's one way of doing core-field masonry. Another way of doing core-field masonry, and you can do it with Besser blocks or bricks, is to have several separate leaves of masonry. So a single brick wall like this is called a leaf of masonry. If we've got two of them side by side, two brick walls side by side and a cavity in between, that's called cavity brick construction. And you can fill that cavity with concrete as well, and that's also a form of core filling. If ever you do that, it's very important that that concrete is put in there in predetermined lifts. So you don't want to just fill the whole wall with concrete. If you fill the whole wall with concrete, particularly if it's bricks, then the bottom of that wall can blow out and you lose all your concrete out the bottom, make a big mess, and you have to have a lot of rectification work for your wall. So typically it's specified in 1 metre lifts. So you put 1 metre height of concrete in there, let that cure, let that harden a little bit, then another metre, then another metre, then another metre, like that. And you can see with these concrete blocks here, we've got some reinforcing poking up through there. So that tells me that this is going to be core field for at least those cavities. So they've got their, so we've got one, then missing two, then another one. So at 390 a block, try to work out what our spacings are. So 1, 2, So that's at 600 centres. So all that reinforcing is happening at 600 centres. So every third cavity will get filled with concrete. What's that?
I say, I'm just trying to find a good picture of the brick things that I took. Unfortunately, I only have one picture. That, the bombshell.